Hello, welcome back to Organic Chemistry Lecture Series. As you can see, I'm still in my house, doing my thing. Still not wearing shoes, but I'm still talking about organic chemistry, so everything's going pretty well here, right? Today we're talking about the acetoacetic ester synthesis. This one is very similar we saw in the previous video in terms of the malonic ester synthesis. Okay, very similar types of steps, and the products will be slightly similar. So with this one here, we're going to have this as our starting material. Where in this time here, instead of having two ester groups, we only have one ester group and this methyl ketone here. We still have our alpha carbon here that's going to have these hydrogens on here that can be fairly acidic, right? In this one, we're going to do similar steps that we saw with the malonic ester synthesis. In terms of step one, it's going to addition of our base, sodium methoxide. Step two is addition of our alkyl halide. And we'll use our alkyl bromide there. Step three is going to be our H3O plus and our heat. As you remember before we saw with our malonic ester synthesis, we're going to deprotonate this using our strong base. We're going to then use our enolate to attack our electrophile, which would be the alkyl halide. And then our third step was going to be H3O plus with heat to do what? It was going to convert this into carboxylic acid, right? And we saw in the malonic ester, we were able to convert this into carboxylic acid and decarboxylate. We're going to do the same thing here. It's carboxylic acid and decarboxylate, right? We can decarboxylate this to give us left over just that methyl ketone, right? And so we'll end up with this as our final compound. R1 group there. So it's a nice way to take our alkyl halide and what? Add a methyl ketone to it, right? It's a great way of doing that. And as we saw with our malonic ester synthesis, if I wanted to go ahead and do this and do one, like we saw before, strong base, two, our alkyl halide, three, I can go ahead and add that base again, and four, R2, add a different alkyl halide, and then five, H3O plus, right? And what do you think we're going to form with this? Remember at this alpha carbon here, we have how many hydrogens to work with? 1, 2. We have 2 hydrogens to work with. So what we can do is we can use our base to deprotonate it, attack this enolate to our alkyl halide, make a new bond. Then we can use our base again to deprotonate, and then we can attack our alkyl halide again, our R2. And then the final step can be what? Hydrolyze this to a carboxylic acid, and then decarboxylate, right? And so from this form here, we still get a methyl ketone. But we can add R1 and R2. We add 2 alkyl groups to that alpha carbon there, right? So we can go either way, right? And what we'll show here is we'll go through the mechanism for this one just to kind of go through it. We won't do the mechanism for this one in this video because we've seen it before with malonic ester, right? And we can do this. Once we do one of them, it's the same thing for this one as well, okay? So we'll go through this mechanism here, right? But it's very versatile in terms of, let's take an alkyl halide and let's put a methyl ketone on it. Now we have a methyl ketone on something, right? We're going to add these 2 more carbons. Actually, we have these 3 carbons, right? And then now we have some more functional groups to work with, like a ketone to work with, right? We can do lots of things with the ketone, okay? So it's a very nice way to add more carbons and give that ketone to work with, right? We know quite a few ways now to put what? To put a halide onto something. We have a halide on something, then we can do all kinds of chemistry now. So let's go through the mechanism. All right. And so we said for the first step, we're going to go ahead and use our strong base. Now remember that we don't need to use that. This is a fairly strong base. And it's good enough because remember, this hydrogen is fairly acidic, right? We already talked about the pK of this to be what? Around 9. So fairly acidic for a CH bond. So this is going to come here. This base is going to take off this proton here. And we're going to generate our enolate. Right? We make our enolate here. Now that we have our enolate formed, now we can take this and we can attack it with our alkyl halide. So let's pick an interesting alkyl halide to work with. How about this one? Now notice here when we pick our alkyl halides, notice that I've used a primary alkyl halide, right? Now remember, this is going to be a strong nucleophile that's going to attack our primary alkyl halide. It's going to go by what? An SN2 type mechanism. And so we want to use an alkyl halide that's going to be very reactive, right, for an SN2 type mechanism. And that's going to be our primary alkyl halides, right? We want to use primary alkyl halides. These will be the most efficient ones. These are going to give us the most product, right? Because we know that it'll work the best because it's the least hindered. So we can get nice attack, great attack here, right? We can attack this carbon and kick off this bromine. No problem there. And it's going to be very efficient. It's going to happen. It's going to go almost all the way to completion, right? We don't want to waste our time using secondary because we're not going to get complete SN2 type attack, right? And definitely we can't do tertiary because those are too bulky, right? We're not going to see what the tertiary alkyl halide. So we'll put this group here. Okay, and we added that group there, and my benzene ring looks not too bad. It's getting better. There we go. Probably close. Oh my gosh. We'll work on our benzene rings. There we go. There we go. Sometimes they're harder than they look, right? All right, then we added this group here. And then remember, we're going to do our next step here will be H3O plus and heat. Again, we've talked about this mechanism already. We've gone through that mechanism a couple times, so you should be pretty bored of doing this mechanism of converting the ester to carboxylic acid. So we're just going to just do it. And again, I'm just going to show this just one more time briefly that we get to a carboxylic acid. But generally when you do this, you're just going to say H3O plus and heat, and this piece just goes away, right? But I just want to, again, make sure we're clear that it goes to a carboxylic acid, and because this carboxylic acid is attached to this carbon that's attached to a carbonyl, we can do that decarboxylation, right? If this carbon was farther away, that decarboxylation isn't really going to happen, okay? But since this carboxylic acid is attached to this alpha carbon, which is directly attached to another carbonyl, we're in that, we can get that transition state where we can do that decarboxylation, okay? Just keep that in mind that this carboxylic acid has to be attached to this carbon that also has another carbonyl attached to it. We went through the mechanism briefly about how this decarboxylation happens, right? It has to go from this cyclic transition state, right? We talked about that. So they have to be on the same carbon here. That's important to do that decarboxylation, okay? So I'm just kind of pointing that out for you. And then we go one more step. Because you know this piece is basically going to leave. So we got to be careful about our carbon count, right? Remember, we added this carbon into our ring, so that carbon's right here. We have this alpha carbon to work with as well, right? The alpha carbon doesn't leave. This one is still there. This one's still here, okay? That's our alpha carbon. Alpha carbon, still our alpha carbon. This carbon here is from our, right there, is from our alkyl halide, okay? So we have to be very careful about our carbon count here. We don't want to lose carbons, okay? 1, 2, 1, 2. They're still there, okay? But now we have this methyl group attached there, right? So we basically, what do we add? We added 1, 2, we added 3 carbons to our what? Our alkyl halide here, okay? With 3 additional carbons. And not only that, we added this ketone group here. And there's a lot of reactions that we can do with a ketone, right? Lots of reactions we can do, all right? So this is our acetoacetic ester synthesis, okay? Very similar to malonic ester synthesis. Now we have 2 ways, versatile ways to add things to our alkyl halides, right? We can put this a ketone source in, okay? Great. And we talked about it before, is you can't do this again. At this stage here, we could add another base in here. We can then deprotonate this and then attack another alkyl halide if we wanted to, okay? So either way we can do that, all right?